Okay, so question 12. The line L is drawn on the grid. Work out the gradient of line L. So I need to pick 2 points. Easiest 2 points I can see there would be there and there. If I then draw my triangle in, okay, so the line is going down, so it's gone down 2, it's gone across 4, so my gradient is the change in y, so minus 2 over the change in x, which is 4. If I simplify that, that's minus a half. Okay. For part B, another line M is parallel to L and passes through the point 6, 2. Find the equation for line M. So, probably the most mathematically correct method would be to use your y equals mx plus c. So we've got y equals minus a half x plus c. And because it goes through 6, 2, that means that when x equals 6, y equals 2. So I'm going to substitute those into there. So we get 2 equals minus a half times 6 plus c. That means we've got 2 equals minus 3 plus c. If I move the 3 across, so I'm adding 3 to both sides, that means these move 5 equals c. So my equation is y equals minus a half x plus 5. Now, I did say that was the sort of most mathematical way of doing it, but in the exam, if you were quite stuck with it, what I would be doing there is going to 6, 2, putting across, and then trying to draw a parallel line. So my line goes like that. If I draw the parallel line, that looks like that. I know the gradient is minus a half, so that would stay the same. Then I'm looking at where's the y-intercept, and you can see there that it's at 5. Okay, now trying to get that perfectly parallel isn't the easiest, and the likelihood is you'd probably go a little bit wrong there, but it might mean that you get at least 1 mark. Okay, question 13. So it's quite a common question comparing distributions. So if we look at the medians, so the median for the boys is at 80. The median for the girls is also at 80. The interquartile range is basically the size of the box there. Okay, so we've got the upper quartile, so 90, minus the lower quartile, 60. So the interquartile range for the boys is 30. The interquartile range for the girls is 90. Take away the lower quartile, which is at 68. So we've got an interquartile range of 22. So they're the 2 things we need to compare, and finally, to get the second mark, we also need to mention the context of it. So I'll try and get that context into the first part there. So the median, and then I'll look back at the top, what am I actually looking at about the points scored by some students in the spelling competition. So the median points scored in a spelling competition is the same for boys and girls. And by doing that, I've managed to get the context of the question, and I've compared the medians. Now I just need to mention the interquartile range. So the interquartile range is larger for boys. And that's it for that one. Right, question 14. You've got 27 to the minus 2/3. So first of all, I'm going to deal with the minus. So that means it's 1 over 27 to the 2/3. Then I'm going to deal with this. So we've got 1 over the 3 on the bottom means the cube root. So the cube root of 27. and then the 2 on the top means I'm going to square that. So we've got 1 over, the cube root of 27 is 3, because 3 times 3 is 9, times 3 is 27, then I'm squaring that, so we've got 1 over 9. For part B, find the value of 1 over 900 to the minus a half. So if we've got something to the minus a half, again, it's going to be 1 over. If I'm doing 1 over a fraction, that means I'm flipping that fraction over. So 1 over 900 is the same as 900 over 1, or just 900. And that's to the power of a half. If something's to the power of half, that means I'm square rooting the 900. Because the numbers are 1 on the top, I don't need to worry about that. Square root of 900, well, we can see that square root of 9 is 3. I've got 2 zeros there, so the square root of 900 must be 30, because 30. Okay, so for question 15, the mode means the most common. So I'm looking for the modal class, that's the group with the most in. So I'm looking for the biggest number, which is 34. So the modal group would be 90 to 100. Okay. For cumulative frequency, that's a running total. So 70 to 80, I've got 4. 70 to 90, that's the first 2 groups, so I've got 4 add 12, so I've got 16. For the next group, 70 to 100, I'm adding all 3 groups up, so I've got 4 add 12 is 16, plus the 34, which is 50. I'm then adding on the 32 to get 82, adding on the 26 to get 88, 108, and then adding on the 12 to get 120. Once you get to that point, I would just double check, going back to the top, the total is 120 and you've got the same total, just to check for any errors. Okay. We're then going to draw that cumulative frequency graph. I'm just going to put those one on top of the other. So my group, the first group 70, 80 goes up to 4. The graph is going up in 2s. We've got cumulative frequency of 4. It should be the end of each group, so my first point goes there. The next group finishes at 90 and goes up to 16. So that would go there. The next one is at 50. 110 is going to go up to 82. 120 is going to go up to 108, and 130 is up to 120, and then that should be joined together in a smooth curve. Okay. Right, for part D, use your graph to find an estimate for the median. So we've got 120 films, so the middle is going to be at 60. So if we go across from 60, we then read down. Okay, it's going up in 1s there, so my estimate for the median will be 102. Okay. Moving to number 15. So if I've got surds, if I'm trying to do anything with surds, it's normally rationalizing, so I'm going to be trying to get rid of that root 2 on the bottom. So if I've got 8 minus root 18 over root 2, that means I'm going to times top and bottom by root 2. So if I'm timesing the top, I'm timesing each of those by root 2, so I've got 8 root 2, take away root 36 all over 2. So we've got 8 root 2, take away root 36 is 6 all over 2. I should have said root 2 times root 2 if you're not sure where the 2's come from. Root 2 times root 2 is root 4, and the square root of 4 is 2. Right, so we're then going to just divide everything by 2. So we've got 8 divided by 2 is 4. So we've got 4 root 2, and 6 divided by 2 is 3. Now, just looking back at how it wants it written, it wants this bit, the root 2, to be second. So I'm just going to rewrite that as minus 3 plus 4 root 2. So my A is minus 3 and my B is 4. Okay, question 16. Make k the subject of the formula t equals k over k minus 2. So I'm trying to get it to be k equals. Okay, I don't like the fraction at the moment and can recognise there I've got 2 k's. So I'm going to times both sides by k minus 2. Okay, so I end up with t bracket k minus 2 equals k. I'm going to expand the bracket, so I've got tk minus 2t equals k, and then I'm going to move anything with a k to one side. Now I can see there that I don't really want that minus to be a minus if possible, so I'm going to move that across. So we've got tk equals k plus 2t, and then I'm going to subtract that k, so we've got tk minus k equals 2t. I want the k by itself, and I've got a k in 2 positions, so at that point the trick is to factorise it. So we've got k bracket t minus 1 equals 2t, and then we're going to divide by that bracket, so it's k equals 2t over t minus 1. Now if you'd rearranged it slightly differently, you might have minus 2t over 1 minus t. That is the same thing, so if you've got that answer, that is fully correct, and the reason that's happened is you've probably taken the tk across at this point to that side, so you had k minus tk. So question 17, got a histogram. The incomplete table and histograms have give us some information about the heights in centimetres of some sunflowers. We need to find out these missing gaps here and use the histogram to complete the table, and therefore also use the table to complete the histogram. So the area of a bar in a histogram represents the frequency. So the area equals frequency. So in this case we know that the area of that bar is going to be 30. So we've got a length of 30, so that must mean the height is 1. Okay, that goes up 1, 2, 3, 4, 5 little squares. So that means every 5 little squares is 1. So I'm now going to complete my scale. So we're going to go 2, up another 5 to 3, up another 5 to 4, up another 5 to 5, up another 5 to 6, 7, 8. Right, now we're going to use that to help us complete our table. So this one, this bar from 130 to 150 has a length of 20. It goes up to 4.2. So for the frequency we've got 4.2 times 20, which is going to equal 84. For the next one, it's got a length of 10. That goes up to 6. So we've got 6 times 10, which equals 60. Now we're going to use the table to complete the histogram. So in this case, to work out the frequency density, that equals the frequency divided by the class width. So in this case our frequency is 40, divide our class width, so the class width is the distance from 160 to 180, which is 20, so the frequency density is 2. For the next one we've got 18, and we're going to divide that by the class width, so that's 180 to 210, so divided by 30. If I'm not sure what that is, I could write it as a fraction and cancel it. So 18 and 30 could both divide by 3. So we've got 6 over 10, which is 0.6. So the 160 to 180 group goes to 2, so that's here. So I would then draw in my bar, and then the next bar goes to 0.6, so that's up 3 squares, 1, 2, 3, and 210 will reach there. And just be careful, don't go up to the 220 because that bar finishes at 210. Okay, so we've done the first two parts of that. Question C, calculate an estimate for the number of sunflowers with a height greater than 170. So for that one, 170 is going to be there, so I need to know the area of half of that bar plus all of that bar. Okay, so we know that bar is 18, and this one I could do it one of two ways. Because I know that that whole bar is 40, that must be 20, or alternatively I've gone along 10 and up 2, so the area of that 10 times 2 is 20. So the estimate for the number of people would be 20 plus 18, which is 38. Okay, if we move on to question 18. The diagram shows a solid cone and a solid hemisphere. The cone has a base of radius x and a height h, which is shown in the diagram. The hemisphere has a base of radius x. The surface area of the cone is equal to the surface area of the hemisphere. Find an expression for h in terms of x. So, in your exam you would be given that the surface area of a sphere is 4 pi r squared. And the surface area for a cone, the curved surface area I should say, is pi r l. Okay, so if we concentrate on the cone first of all, we've got the curved surface area of the cone, so that would be pi r, and then if we've got h, in order to work that out, to work out the L part, I'm going to need to do the fact that L squared equals h squared plus x squared. So I'm going to have pi r and the square root of h squared plus x squared. I'm then going to add on pi r squared. So if I then substitute in my r, which is x, I've got pi x times the square root of h squared plus x squared plus pi x squared. For the hemisphere, we've got a sphere that we're halving, so we've got 4 pi r squared, and we're going to half that, and then we're going to add on the flat surface at the bottom, so add on the pi r squared at the bottom. So that's going to give us 3 pi r squared. 4 divided by 2 is 2, plus the 1 pi r squared. So substituting in our x, that gives us 3 pi x squared. So if I then go and have a look back at the question, we can see that the surface area of the cone is equal to the surface area of the hemisphere. So if we write these two things equal to each other, we've got the cone, which is pi x root h squared plus x squared plus pi x squared equals 3 pi x squared. We're then going to simplify that because we were trying to get it to be h equals. So I'm going to take away pi x squared from both sides. So I now have pi x root h squared plus x squared equals 2 pi x squared. I'm then going to divide by pi x to get rid of this in the front. So if I divide that by pi x, I'm left with the square root of h squared plus x squared, and that's going to equal 2x. Right. I now want to get rid of the square root sign, so I'm going to square both sides. So we've got h squared plus x squared equals 2x squared. 2x squared is 4x squared. And I'm going to take away x squared, so h squared equals 3x squared. And then to finish that off, I need to square root both sides, so h equals the square root of 3x squared. And that's my final answer. So h equals the square root of 3x squared. I could also write that as root 3x. Okay, question 19. So we've been given that OA equals 2A, OB equals 3B. We need to find AB in terms of A and B. So it's fairly straightforward. I don't know what this line is, so to get from A to B I could go from A to O and then go from O to B. A to O is minus 2A, and then O to B is plus 3B. So that's my answer there, minus 2A plus 3B. So the next part, P is the point on AB such that AP to PB is 2 to 3. So I'm going to write on there A to P, and I'm going to put 2, P to B is 3. Show that OP is parallel to the vector A plus B. Okay, so I need to find the vector OP. So to get from O to P, I would go from O to A, and then I would go A to P. O to A is straightforward, that's 2A. A to P, if I maybe write that just to one side here, A to P is 2 out of 2 plus 3 is 5, so it's 2/5 of the way along AB. Now AB we've already worked out, so it's 2/5 of minus 2A plus 3B. So if I substitute that back in here, we've got plus 2/5 minus 2A plus 3B. We're then going to simplify that, so we've got 2A minus 4/5 A, because I'm timesing 2/5 by minus 2, plus 6/5 B, so 2 times 3 is 6. Then I want to simplify that, so 2 take away 4/5 equals 1 and 1/5. So we've got 1 and 1/5 A. 6/5 is the same as 1 and 1/5 B. And that equals, if I take 1 and 1/5 out, I've got 1 and 1/5 times A plus B. Now that is a multiple of A plus B. So OP is a multiple of A plus B, and therefore parallel. Right, question 20, we've got x over 2 take away 2 over x plus 1 equals 1. We're asked to solve the equation, so we're looking to finally get x equals. So first of all I'm going to bring this fraction together. In order to do that I need to times the denominators to find the lowest common multiple. So I'm going to have 2x plus 1 take away, and then on the bottom of the second one the same again, so 2 bracket x plus 1. So x over 2, to get 2 bracket x plus 1, I've times that by x plus 1, so I've got x bracket x plus 1. And then on this one, I've multiplied this by 2, so I've got 4 on the top. 2 times 2 equals 1. Right, when we're subtracting fractions, we bring the denominator together, so the denominator stays the same. And then we take away the top. So we've got x squared plus x, if I times that out, take away 4, and that all equals 1. Now I want to get rid of the denominator there, so I'm going to times both sides by 2 bracket x plus 1. So that's going to leave me with x squared plus x take away 4 equals, If I times them by 1, it just stays the same, so I've got 2x plus 1. Right, if I multiply that out, I've got x squared plus x take away 4 on that side equals 2x plus 2. Okay, I now have a quadratic because I've got x squared, so I want to make that equal to 0, so I'm going to move these two, 2x plus 2, over to the other side, so I'm going to subtract 2x and I'm going to subtract 2 from both sides. So that's going to give me x squared take away x, take away 6, and that's going to equal 0. Now I'm trying to solve this. It's a non-calculator paper, so I'd always prefer to be doing it as factorising. So I'm looking for what multiplies to make minus 6 and adds to make minus 1. So that would be minus 3 and 2. So we've got x minus 3 and x plus 2 equals 0. So x minus 3 equals 0, which means x equals 3. Or we've got x plus 2 equals 0, so x equals minus 2. So I would just then finalise my answer, so x equals 3 or x equals minus 2. Okay, final question. We've got two triangles, T1 and T2. So we've got x, and we've got 30 degrees. So we've got a side, an angle, and then a side. And then we've got another triangle where we've got the base and we've got the height. The lengths of the sides are in centimetres. The area of triangle T1 is equal to the area of triangle T2. Work out the value of x and give your answer in the form a plus root b. So, in terms of the triangle 1, the area, so we don't know the base and height, so we're going to have to use our trig form. So it's going to be a half AB sine C. So in this case our a and b are x, so we've got half x sine 30. So that equals a half x squared sine 30. Okay, it is a non-calculator paper and we've got to try and work out what sine 30 is. So you've got different methods to work that out. One method would be to use your table. So we've got 0, 30, 45, 60, 90. So sine, it's always going to be over 2. It's always going to be the square root. And we'll go 0, 1, 2, 3, 4. So sine 30 equals root 1 over 2, which equals a half. So if I put that back in, we've got a half x squared times a half, and a half times a half would be a quarter. So we've got a quarter x squared. If we then go to triangle 2, we do have the base and height for that, so we don't need to rely on our trig formula. So we can do x minus 2 times x plus 1 divided by 2. So we're going to make those two things equal to each other. So we've got a quarter x squared equals x minus 2 x plus 1, and we're dividing that by 2. If we then multiply everything by 4, so times both sides by 4, that's going to get rid of that fraction. So we've got x squared equals 2 bracket x minus 2 x plus 1. We're then going to simplify that. So if I multiply this out, we've got x squared equals 2 x times x, x squared. I've got minus 2x plus x, so we've got minus x. Minus 2 times 1 is minus 2. Then just going to go up to here. So that's going to leave me with x squared equals 2x squared minus 2x minus 4. I'm going to move the x squared across, so we've got 0 equals x squared minus 2x minus 4. Now it's a non-calculator paper. I can't factorise that. there's nothing that multiplies to make minus 4 and adds to make minus 2. There's also a clue in the question in terms of leaving it as a plus root b. So the route I'd be going down here would be completing the square. You could also use the quadratic formula. So if I try and complete the square there, we've got x minus 1, because I half the 2. I take away that number squared, so I'm taking away 1 squared, take away 4. So we've got 0 equals x minus 1 squared, take away 5. If I move the 5 across, so by adding 5 to both sides, we've got 5 equals x minus 1 squared. And they're going to square root both sides, so we've got root 5 equals x minus 1. Now be careful here, you should have plus or minus to start off with, and I'll explain how we get rid of the minus in a moment. So if we then add 1 to both sides, we've got 1 plus or minus root 5 equals x. Now, in the context of this question, we've got a triangle with length x. Root 5 is going to be 2 point something, so if I do 1 take away 2 point something, that's going to be negative. I can't have a negative length, so that's why I would only have the positive value. So then I would finalize that as being x equals 1 plus root 5, so it stays as a positive. Okay, and that's our paper finished.